Welcome to the testing laboratory, guys. I am your lead tester, and today we are running a highly specialized, absolutely critical exam mythbuster session. We are taking all those viral, low-effort study hacks and terrible student revision assumptions you've seen floating around online, and we are going to stress test them live. We're testing them directly against the official Cambridge Assessment International Education Standards, specifically for AS and A-level mathematics 9709. If you look at our mark volatility grid on the monitors here, you'll see our target for today, the theoretical architecture of logarithmic and exponential functions. We are talking about that absolute powerhouse of a concept, the inverse relationship between e to the power of x and the natural log of x. We are going to completely deconstruct the actual mathematics today. We'll examine exactly how these functions operate, how they systematically undo each other, and how they behave in advanced algebraic manipulation. If you've been relying on rote memorization, or the myth that just writing down a bunch of random formulas gets you credit in paper 2, prepare to have your entire strategy completely rewritten. We demand evidence here, and we reject fake shortcuts instantly.
To pull this off, we're going to run a strict 6-part diagnostic testing protocol today. First up, the 15% trap. Then we hit core concepts, followed by the method mark strategy. After that, we'll look at some raw examiner warnings, introduce our custom deconstruct solve evaluate protocol, and finish with a final exam quality audit. This is the exact sequence we'll use to audit the examiner reports and reveal what actually survives the stress test on exam day. Let's load up the first cognitive target.
Section 1, the 15% math trap. Okay, let's dive into this because this specific topic is an absolute high-stakes battleground for your final grade.
15%. You heard me right, our data metrics show that logarithmic and exponential functions account for approximately 15% of the total available marks in paper 2. Guys, that is massive. That is literally the difference between an A and a B, or a B and a she, dedicated entirely to understanding inverse relationships and multi-stage analysis. It's not just some passing minor topic you can gloss over, it's a foundational pillar of the Cambridge 9709 syllabus. Your understanding here literally cascades into your ability to solve complex equations, graph intricate nonlinear models, and perform advanced calculus down the line. If your foundation cracks here, the entire structural physics of your exam paper collapses. You simply cannot afford to get this wrong.
So, I have to ask you, are you leaving 15% of your marks on the table by relying on generic study hacks? Think carefully about your current revision strategy. We see students all the time. Let's call one of our simulated students here in the lab Tester Alex. Alex believes in myth number 1. If I just write down more lines of working, dump a bunch of memorized formulas onto the page, I automatically get more marks. Alex is doing what we call unstructured page dumping. But here's the reality check from the examiner's grid. Doing that triggers an immediate marking penalty. You are walking straight into a trap if you just copy-paste formulas without structural logic. Let's look at what the examiners actually demand from you mathematically.
Moving to Section 2, Core Concepts, Inverse Relationships. We are now transitioning into the theoretical architecture of the topic, where precise definitions are absolutely everything.
Now, what's really interesting about this breakdown on your screen is that the Cambridge Assessment Framework doesn't just want superficial breadth. It targets analytical depth across 3 very distinct cognitive domains: knowledge, application, and analysis. Let's bring in another one of our lab testers, Tester Sam. Sam is a fast writer who thinks using massive mathematical jargon compensates for ignoring the core command word of the prompt. Sam tries to show knowledge by just regurgitating a formula, but if you only do that, you're missing 2/3 of the picture. You have to apply the inverse relationship to actually transform the equations. You need to explicitly know exactly how applying the natural logarithm to e to the x isolates the exponent. You're effectively undoing the operation. When you take the natural log of e to the x, you utilize the power rule to bring the x down, giving you x times the natural log of e. And since the natural log of e is precisely 1, you are left with just x. That explicit cancellation, that is the functional engine driving this entire topic. And then comes analysis. Analysis means interpreting the roots you find, rejecting invalid solutions like, trying to take the logarithm of a negative number, which is a huge red flag, and actually proving the validity of your mathematical model.
Do you want to know the absolute secret weapon of top-scoring candidates? It's integration with other syllabus areas. Principal examiner reports highlight this over and over again. When you can connect the inverse relationship of e to the x and ln x to calculus, your analytical depth just skyrockets on the examiner's grid.
I'm talking about knowing for a fact that the integral of 1 over x is the natural log of the absolute value of x, or knowing how to differentiate a complex composite exponential function using the chain rule. Referencing these cross-topic connections is exactly how you signal to the examiner that you truly command the algebra. You aren't just reciting a trick, you are demonstrating full architectural control of the math.
Section 3. The method mark strategy. Let's move into the core methodology of our lab, because if you want a legitimate exam hack, one that works strictly within the rigid Cambridge framework, this is it.
Let's run a live simulation in our co-op stress testing lab. We've got Alex and Sam at their diagnostic consoles, and they are trying to tackle an equation y equals a times b to the power of x. Alex wants to use a generic pre-written template and just jump straight to the final answer. But Sam realizes something crucial. Without a direct, tailored analytical link, the entire paragraph structure of their working out is going to collapse. They are arguing right now over the structural physics of their answer block. Alex says, just write the final logarithmic form. But Sam says, no, we have to show the method mark strategy. And Sam is totally right. The method mark strategy is about earning marks awarded strictly for demonstrating a logical, step-by-step mathematical process, regardless of the final answer. Examiners are auditing your systematic processing. Explicitly writing down the step where you take the natural logarithm of both sides of that equation and correctly expanding it to ln y equals ln a plus x times ln b is a specific, scoreable maneuver. Even if your final arithmetic later on is slightly off, that method mark is locked in and secured. The final answer is secondary. The process is everything.
System pause. Look at the warning indicators flashing. Before we blast away the biggest exam lie of the century and show you what actually wins marks, we need to secure your academic defense network. Subscribe to Ace the Exams right now at the handle @AceTheExams and turn on all notifications. No matter if you are tackling Cambridge IGCSE, O-levels, AS, or A-levels, do not let bad study advice compromise your final results. Okay, alarm deactivated. Back to the lab. So, let's pose a serious stress test question. If you theoretically understand this process, why do multi-stage analysis marks completely collapse for so many students mid-paragraph? The answer is that their evidence drops out of compliance. They ignore the proper procedural frameworks, they get impatient, rush to the final answer, and skip the logical algebraic steps, like explicitly showing the cancellation of E and ln. By doing that, they completely destroy their ability to pick up method marks along the way. Their structural foundation just crumbles.
Section 4. Top 3 examiner warnings. We are now pulling raw, unfiltered data straight from principal examiner reports to bust these dangerous myths once and for all.
Welcome to the interactive viewer lie detector arena. Assessment 1. Spot the fake shortcut. Look at the comparison on your screen. There is a massive, highly volatile gap between generic internet study hacks and the harsh reality of the mark scheme. Memorizing formulas and ignoring presentation will fail our stress test every single time. The top 3 mistakes examiners flag constantly are 1. Candidates using the wrong approach for the specific context, 2. Forgetting strict format conventions, and 3. Providing non-specific generic mathematical answers. For example, imagine a problem explicitly featuring the base of the natural logarithm, e. If you try to use base 10 logarithms to solve it, your logic breaks down on line 1, marks are completely forfeited, and the myth status bar flashes a giant red busted. It fundamentally misaligns with the context.
I am going to read this explicit examiner alert to you verbatim because it is absolutely crucial. Quote, "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. This completely busts the myth of the generic answer. If a problem asks you to calculate population growth using the continuous growth model, p equals p sub 0 times e to the power of kt, and you just blindly manipulate the logs without stating what the constant k actually means for that specific population's growth rate in your context, you lose the marks. Welding your data to your analysis is non-negotiable. Context is literally everything."
Section 5. The Deconstruct, Solve, Evaluate protocol. So the crucial point is, how do we fix this? We inject a high-yield, bulletproof procedural framework to counter these examiner warnings.
Let's walk through this systematic 5-step sequence step by step. This is how we rewrite our responses line by line to create an unshakable, top-band mathematical asset. Think of this as the math equivalent of the Peel structure for essay writing. Step 1. Deconstruct the question. What is the exact mathematical command word? Are they asking you to solve, show that, or evaluate? Step 2. Extract the relevant algebraic data from the texts or given models. Step 3. Select your framework.
Are you using natural logs to solve for an unknown exponent, or are you exponentiating both sides to solve for x trapped inside a logarithm? Step 4. Execute with crystal clear algebraic notation. And Step 5. Present with correct terminology. Systematically following these 5 steps guarantees strict adherence to Cambridge conventions and locks in your marks. All right, assessment 2 in our arena, the data matrix sweep. I'm going to run a visual countdown here. Look at these presentation standards. Presentation directly dictates your marks in these exams. Proper headings, required. Terminology, it must be mathematically precise. Formats must be appropriate, and annotation must be absolutely clear. If your working out looks like a chaotic, unstructured scribble, you are literally throwing 15% of your exam away. The examiner needs a clear, annotated map of your algebraic reasoning. Seriously, sometimes literally writing the words, "take the natural log of both sides," right next to your equation is the absolute best way to document your logical path. Section 6. The Final Exam Quality Audit. And this brilliantly illustrates the evaluation phase that separates the top-tier, elite candidates from the rest of the pack. Let's look at Tester Alex and Tester Sam's final, high-scoring text block. The myth status bar for generic shortcuts is officially flashing busted, and our structural strategy is glowing confirmed. Elite problem-solving requires evaluative thinking. You need to question assumptions and consider the limitations within a mathematical model. When asked to perform comparative analysis, like comparing an exponential decay model to a linear decay model over time, you have to identify similarities and differences in the rates of change explicitly. And most importantly, you must justify every single decision with hard algebraic evidence, explicitly showing your logarithmic conversions to the examiner.
I'm going to leave you with an intense, provocative question. If a strict Cambridge examiner audited your last past paper response right now, today, would your method survive the stress test? Would it pass the deconstruct, solve, evaluate protocol? Let's distill today's session into 3 universal truths. Number 1, the 3-step command word scan, always know what the question is actually asking. Number 2, the mark per minute budget rule. Don't waste time dumping unstructured equations that don't earn method marks. And number 3, the post-writing quality audit. Always check your inverse operations. If your current strategy fails these truths, ditch the generic online hacks immediately. Subscribe to Ace the Exams at the handle @AceTheExams right now. Click that notification bell for our weekly myth-busting sessions and drop a comment down below sharing the weirdest exam hack you've seen online so we can stress test it in the lab next. Implement this audit protocol immediately, and I'll see you next time.